Hello my dear students, welcome back to EZEE Notes. Today we will be continuing the chapter 4, that is refraction of light at plane surface, in which we will be studying part B, that is refraction through prism. So let us see what is a prism. Prism is a transparent refracting medium bounded by at least two plane refracting surfaces inclined each other at certain angle. See, two plane refracting surface inclined at some angle A. This is angle of incidence. Okay. These are the two refracting surfaces. It consists of two triangular bases and three rectangular lateral surfaces. See, one base will be front, other base will be back. Two triangles, and 1, 2, and 3 will be rectangles. So it will be like that. This is a prism. So how is the refraction happening in prism? Let us consider a prism with refractive index n or mu, and the angle of prism A is kept in air as shown in the figure. We will draw the figure now. Array. Okay. We don't need. We will draw 2D surface only. Okay. Chalo. So yeah, this is actually a prism. Okay, this is a prism. Now, what happens is, let us increase its length. Can't we increase? Yeah. Now I'll explain you easily. Array. So, this is the angle of prism A. Okay. Now there will be an incident ray. Okay, we'll change the color of incident ray. This is an incident ray. I. Incident ray. Now this is the normal, right? What will be normal? Perpendicular to surface. A line perpendicular to surface is called normal. Line perpendicular to surface is normal. Okay. So this angle will be incident angle I1. Okay. Now what happens? It's going from rarer to denser medium. So it will bend towards normal. So also we can remember it will bend towards base. It will bend towards base. So let us bend it towards base like this, somewhat like this. This is a refracted ray, and this is angle of refraction 1. Now again, this is our normal perpendicular line to the surface. This is our normal. So this will be angle of refraction 2. Same as a glass slab, right? This is going in a not a rectangular, it's a triangular glass slab. Okay. Now from denser to rarer medium, it will bend away from normal. It will bend away from normal, like this, away from the normal. This is our emergent ray, and the angle of emergent we can say it as I2. There is nothing but E. So this is the actual path traveled by the what? Light ray inside of the glass prism. So what is deviation here? So let us draw deviation in a different color. We'll take this white color. This was the actual path. This is the actual path. The final path was this. So this is nothing but the deviation. This is the deviation delta. Okay. Initial and final path rays. If we meet them, the angle between them will be the actual deviation. So what happens? Incident ray, then it refracts inside the prism, then again it refracts outside the prism from denser to rarer medium. So the angle between incident and emergent ray is called angle of deviation. Okay. So this is the actual process of refraction through prism. Now we have one derivation. What is the derivation now? So we need to find the angle of deviation here. So here We have two things here. Let us consider these points as P, Q, this as N. Okay, because it's normal, right? N. So from triangle P and Q, from triangle P and Q, let us consider this angle as theta, some theta. So R1 plus R2 plus theta, R1 plus R2 plus theta will be equal to 180 degrees, right? Yeah. The sum of angle will be 180 degree for triangle. Now we have a quadrilateral P, A, Q and N. So from a quadrilateral P, A, Q, N, we can say that, see, this angle will be 90 degrees, right? This angle will be what? See, this is 90 degrees and this is also 90 degrees, because it's normal, from normal, surface to normal is 90 degree. So we can say that A plus 90 degree plus 90 degree plus the another angle is theta is equal to 360 degrees. So A plus 180 degree plus theta is equal to 360 degrees. So A plus theta is equal to 360 minus 180 will be 180 degrees. This is equation 2. So from equation 1 and 2, we can conclude that from equation 1 and 2, we can say that R1 plus R2 plus theta is 180, A plus theta is 180. So A is equal to R1 plus R2. We can say this, A is equal to R1 plus R2. Now let's find deviation. Now delta is equal to, there are deviation two times, one is here, other one is here. So we can say it as delta is equal to delta 1 plus delta 2. So delta is equal to delta 1 is I1 minus R1 and delta 2 is I2 minus R2. So delta is equal to I1 plus I2. In these two, minus is common. So we can take R1 plus R2. But R1 plus R2 was A. So we can replace it with delta is equal to I1 plus I2 minus A. This is the formula for deviation. Okay. Formula for deviation. Now, let us learn this thing. If for minimum deviation, for deviation to be minimum, I1 should be equal to I2, that is nothing but I, and R1 should be equal to R2, that is nothing but R. So if I1 and I2 becomes equal, I plus I 2I, so delta minimum will become 2I minus A. Remember this as well. And A will become R by 2, because, sorry, 2R. A will become 2R, because R1 plus R2 was A, right? So A will be 2R and delta minimum will be 2I minus A. Okay, next. Factors affecting the angle of deviation. What are the factors affecting here? First one, the angle of deviation depends on angle of incidence, material of prism, that is nothing but refractive index, angle of prism, and also the color or the wavelength. See, it will depend on angle of incidence, angle of prism, and also the material mu. If it depends on mu, it also depends on wavelength, because mu is inversely proportional to wavelength, right? Yeah. Next, dependency of an angle of deviation on the angle of incidence. How it depends? So it is experimentally observed that the angle of incidence increases, the angle of deviation first decreases. As soon as the angle of incidence increases, the angle of deviation decreases. See, the angle of incidence increases, then the angle of deviation first decreases, reaches to minimum, and then increases. What happens? As soon as angle of incidence is increasing, the deviation keeps on decreasing and reaches to minimum. Where it will be minimum? When I will be equal to E, right? That is nothing but angle of incidence will be equal to angle of emergence. At that point, it will be minimum. We have learned here. See, delta minimum, when it will be I1 is equal to I2. That is nothing but incident angle and emergent angle will be same. At that time, deviation will be minimum. Again it will start increasing. It is found that the angle of deviation becomes minimum when the angle of incidence is equal to angle of emergence. We have learned it. I1 is equal to I2, or when R1 is equal to R2. That is nothing but delta minimum is equal to 2I minus A. Next, dependency of angle of deviation on angle of prism. How it depends on angle of prism? After solving, we'll get this by using Snell's law and all. We'll get this final formula, that will be delta is equal to mu minus 1 into A. It will depend on angle of prism as well. Next, on the wavelength. See, in transparent media, see, simple. It will also depend on mu, right? Deviation is directly proportional to mu. Refractive index decreases as wavelength increases. Why? Refractive index decreases as wavelength increases. We have studied that. But deviation also decreases when refractive index decreases. Deviation decreases when refractive index decreases. It means that more the refractive index, more is the deviation. See, in transparent media, so the refractive index is maximum for violet. Acha, we are studying about wavelength, right? Okay. Deviation is inversely proportional to wavelength. Deviation is inversely proportional to wavelength. Simple. Refractive index decreases as wavelength increases. So, also we can say that here we might have our editor has missed one part. Dependency on refractive index. So delta is directly proportional to mu. Delta is directly proportional to mu. More the refractive index, more is the deviation. More is the refractive index, more will be the deviation. So if the refractive index decreases, wavelength increases. So we can say that delta is inversely proportional to wavelength. More is the wavelength, lesser will be the deviation. So see here, whose wavelength is more? Red light. See, so red light will deviate less. Deviation of red light will be lesser, and deviation of violet light will be more compared to red. Let's go for the questions. Draw a ray diagram to show the refraction of monochromatic ray through a prism when it suffers a minimum deviation. Simple. This will be the ray diagram I have drawn here. But I1 is equal to I2 and R1 will be equal to R2. You should remember that because it's asking for minimum deviation. Next, the diagram below shows the ray OP, okay, traveling through an equilateral prism of certain material. Okay, what we need to find? What we should find? Find I2. Find I2. Okay, let us find I2. So it is an equilateral prism. So we know that delta is equal to, delta is given here, right? 43 degree. Delta is equal to I1 plus I2 minus A. So delta is 43 degrees is equal to I1 is 65 plus I2 minus A is angle of prism. Equilateral means angle of prism will be 60. So 43 degrees is equal to 65 minus 60 is 5 degrees plus I2. So I2 will be equal to 43 degree minus 5 degree. So I2 is 38 degrees. Okay. What is the ray QS called? QS ray is called as emergent ray. It is called as emergent ray. Okay. Next, the last question. A monochromatic ray of light is incident on an equilateral prism placed at the minimum deviation position at an angle of incidence 45 degree as shown in the diagram. Okay. Copy the diagram and complete the path of ray of PQ. Let us complete the path. So it will bend like this, then it will go like this. This is the normal. In this way, right? This will also be equal to 45 degree because for minimum deviation. State two factors on which angle of deviation depends. We have four factors. Simple. Angle of incidence, angle of prism, refractive index, and wavelength of light used. Okay. So done with this part. So let's meet in the next part, that is part C. I think real depth and apparent depth. So till then, keep studying and keep following EZEE Notes. Bye bye.